This is question number 10 of homework 4. Hula Enterprises is considering a new project to produce solar water heaters. The finance manager wishes to find an appropriate risk-adjusted discount rate for the project. So that means this basically means the cost of capital, right? The equity beta of hot water, a firm currently producing solar water heaters, is 1.5. So this firm, hot water, is already producing solar water. So that's the so-called comparable firms for the Hula Enterprises, this new project. So we know it's equity beta, and hot water has a debt to total value ratio of 0.4. So 40% of the firm value is financed by debt, and 60% is financed by equity. The expected return on the market is 0.12. So market return is 12%, and the risk-free rate is 1%. Suppose the corporate tax rate is 39%. Assume that debt is riskless throughout this problem. So riskless, risk-free. So this last sentence simply tells us the beta for the debt is 0, or the return on the debt is simply the risk-free rate, which is 1%. And the rounding requirement, round your answers to 2 decimal places. So this is a kind of a standard question of using the comparable firms to estimate the cost of capital, or the weighted average cost of capital. So to do that, we can first look at the PowerPoint lecture slides. So just go to our website and session 4 and click on the session 4 PowerPoint slides. Once you finish downloading, just open it. And then we can find the steps we need to take in order to use the comparable firms to estimate the cost of capital. So estimate WACC using comparable firms. So the steps here is 1, find the comparable firms whose leveled equity beta are available. So basically the setup already told us about the equity beta of the comparable firm, which is 1.5, right? So that's known unlevered to estimate asset beta based on the above equation. So unlevered here means that we can calculate the equity beta if the firm, under the situation that if the firm doesn't have any debt. So that's unlevered equity beta. And that's also called asset beta. And how do we do that? It's by another equation on the PowerPoint lecture slides. That's basically beta asset. So asset beta equals, so beta asset is also what the symbol can also be beta 0. Beta 0 is beta asset. That equals debt value ratio. So debt over debt plus equity. So that's basically the debt value ratio times the beta on debt plus equity value ratio times the equity beta. So the asset beta is the weighted average of the debt and equity betas. That's basically their relationship. And from that, we can figure out the asset beta, because we know the equity beta, and we also know that based on the setup that all the debt are risk-free in this problem. So we can know the debt beta is basically 0. So based on that equation, we can figure out the acid beta. So step 2, we can do that. And step 3, do this for each comparable firm. So here we only have one firm, so that's just one firm is very simple. So obtain multiple estimates of beta acid, then take an average. This step basically we don't need this here, but we will need that in the case analysis. 4, the lever based on beta acid and the debt ratio of our current project. So once we know the beta acid of the comparable firm, we can actually use the same number to our project because the comparable firm has the same acid beta as the project, as our project, because they are in the same industry. So their acid beta have to be the same. So we can bring that acid beta over to our project. But we cannot directly use that acid beta because our project is also financed with debt. But acid beta means that it's the equity beta without any debt in the capital structure. So we have to relever based on the project, the capital structure of the project. It's no longer the capital structure of the comparable firm, because when we do the unlevering, we are using the capital structure of the comparable firm. But here, when we do the relever, we have to use the capital structure of our project. We're using the same equation here because their relationship always holds, but this debt value ratio will change depending on our project. So that's the difference when we do the relevering. And so that's basically the steps we need to take in order to estimate the equity beta. So this is the steps we need to take to estimate the equity beta of our project. And once we have the equity beta, because the debt beta is given, that's 0, so we can figure out the weighted average cost of capital based on the betas. Because we can also use the CAPM, capital asset pricing model, to figure out the cost of equity based on the equity beta and the cost of debt based on the debt beta, and then we do the weighted average cost of capital calculation after that. So that's basically the steps we can take in order to figure out the answer to this problem. So now let's go to each step, each part of this question. First part is the expected return on the unlevered equity, so that's R0, for the solar water heater project is. So how can we figure out the unlevered equity return? It's not beta. Once we know, if we can figure out the equity beta, unlevered equity beta, then we can use the CAPM, right? Capital asset pricing model to figure out the return. So then the question here boils down to how can we figure out the acid beta? And that's what we just talked about. We can do the unlevering, right? Because we know the comparable firm. We know the equity beta of the comparable firm. And we know the debt beta of the comparable firm. It's 0. So we can figure out the acid beta. So acid beta is basically the comparable firm. Comparable firm, that's the solar hot water. Hot water is beta E. So that's given. It's always give me some trouble here. When I do that, I have to actually leave some space. Otherwise, it will just automatically convert that into that sign. So the hot water is 1.5 equity beta, and the debt beta D 0, right? And so, the capital structure of the comparable firm hot water, the debt value ratio is 0.4. So D over D plus E. Remember, this is hot water, HW. That's 0.4. Hence, D over D plus E. Again, this is hot water, very important, because later on we'll have to use the capital structure of our own project. Right now, we're using the capital structure of the comparable firm. So it has to be 1 minus this debt value ratio. That equals 1 minus, okay? So now we can do this asset beta 0. And again, this is hot water, right? So that equals, going back to our equation here, so it's a weighted average of the debt beta and equity beta. So that equals the weight on the debt value ratio times 0, which is the debt beta, plus equity value ratio times equity beta. So yeah, I think here I missed, this should be D. So this gives me the asset beta for the comparable firm. So now, because the comparable firm is in the same industry as our own project, the Hula Enterprise, so we can bring that over, right? Beta. So, and Hula Enterprise, make it here. This is our own project, okay? So now we can bring this beta 0 over. It simply equals that, right? Equals 0.9, same as the comparable firm. And so, and then based on the equity beta, based on the asset beta for beta 0, we can figure out the return on unlevered equity, which is R0. And we need to know the risk-free rate. We also need to know the market return, and we can use the CAPM. So CAPM can give us the R simply equals RF plus beta times RM minus of F. So we know beta, that's 0.9, and this RM, this is the market return, that's 12%, right? 0.12. And this RF, 0.09, 0.01. Okay, so then we can figure out this R0. Just add this beta 0. Everything is 0. So now go back to, so this is a risk-free rate, 0.01, and RM, that's 0.12. Hence R0, that equals RF plus beta times RM minus RF. So this gives me 0.109. And we need to convert that into percentage, right? So that if you convert that, obviously that will give us 10.9%. Okay, so that's the part one, part A. So part B, if Hula is an equity financed firm, the weighted average cost of capital for the project is. So if the firm doesn't have any debt, that's what the equity financed firm means, right? If the firm doesn't have any debt, that's simply the unlevered. It's unlevered equity, doesn't have any leverage, doesn't have any debt. So in that case, the weighted average cost of capital has to be equal to the cost of equity because there's no debt in the firm's capital structure, right? And the cost of equity in that case is simply the cost of unlevered equity. And that's simply this number we just calculated. So we just copy that number here, 10.9. So this basically is a conceptual question, right? Once we understand the weighted average cost of capital under an equity financed firm is simply the return on the unlevered equity, then we know the answer directly without any calculation. C, if Hula has a debt to equity ratio of 0.6, the weighted average cost of capital for the project is. So that's basically here we're given the capital structure of our project, Hula, right? The debt to equity ratio. So we provided with D over E. This is Hula Enterprise. We're given that to be 0.6. So this can tell us D, but ultimately we have to figure out D over T plus E, right? Debt value ratio. Again, this is debt value ratio for our own project, Hula Enterprise. But if we know D over E, this is simply the D over E over D over E plus 1. That's D over D plus E. So to understand this, you can just assume that D is 0.6. Hence, E must be 1 because D over E must be 0.6. So if D is 0.6, E is 1. So then you can understand this. So this simply is E6, that's the 0.6 over 0.6. That's D over D plus E. E is 1, right? So even though this seems to be a very arbitrary assumption, right? Because I assume that D is 0.6, hence E is 1. But what if D is 200 or 205, whatever number? But as long as the ratio keeps the same, that will not affect this D over D plus E. So you can safely assume that D is 0.6, hence E is 1, and then just calculate D over D plus E. Hence, E over D plus E, again, this is Hula Enterprise, that's simply 1 minus this, right? Okay. So this capital structure D over E can tell us how to get the D over D plus E and the E over D plus E. But why do I need that? I need that because I want to figure out the beta, equity beta for Hula Enterprise. This equity beta here is for the comparable firm, hot water. Everything here is hot water, but beta D doesn't matter because that the setup tells us the debt is risk-free throughout this problem. So I don't need a symbol here, but I will need a symbol for this beta equity. But how can we figure out the equity beta if the firm does have debt? Because this project does have debt, right? D over D. D is not 0. But we know this beta 0. So how can we figure out beta E, the levered beta. The beta zero here is unlevered equity beta, but this is levered equity beta. Again, going back to that equation here. When we do the unlevering, we use the equation from, we know every input on the right hand side, right? We know the beta debt, beta equity, and capital structure, so we can calculate beta asset or beta zero. But when we do the unlevering, we know the beta zero because that's brought over from the comparable firms, beta zero. And in this case, we know beta debt, that's zero. So we can calculate this beta equity. This is the levered equity beta. And given the equity value ratio. So that's how we can figure out that. And then if this beta delta is zero, so this term vanishes. Only the second term remains. So we know beta zero and we know this equity value ratio, right? We just calculated that. This is the equity value ratio. So then if we divide both sides by this equity value ratio, then we can figure out this levered equity beta. So that's how we solve that. So this basically equals this beta zero divided by this equity value ratio, right? So that's simply the equity beta. Again, so to make you better understand, so why don't I write this down in this so you can see more clearly what I mean by that. Basically, beta zero equals d over d plus e beta d plus e e over equity value ratio e over d plus e times beta e. Because beta d is zero, so this term is gone. We're simply left with the second term. So we know beta zero, we know e over d plus e, so we can solve out this beta e. So beta e, if we divide both sides by this e over d plus e, beta zero divided by e over d plus e. So that's basically what I did. I just divided this 1.44 is obtained by dividing this beta zero by this e over d plus e. So that's simply what I did. So that's the levered equity beta. So once we know the beta, we can again use the campaign R to figure out return, right? So now this is the return for the Hula enterprise. This is simply the RF, risk free rate, plus beta times RM minus RF. And RD RD is simply the risk-free rate, right? Because all the debt in this problem is risk-free. So the return on debt must be equal to the return on the risk-free asset, which is 1%. And we know the return on equity, the cost of equity, that's this number. And we know the cost of debt. And we also know the capital structure of our project. So the final step is to figure out WACC. That's simply the debt value ratio times after tax. Remember, it's after tax. And let me write down the tax rate. TC, that's equal 39%, right? Going back to the setup. It's corporate tax rate is 39%. So then is D over the debt value ratio times after tax cost of debt plus equity value ratio times cost of equity. So that's our WACC, weighted average cost of capital. Again, this number, we can format it. Right click on the cell and choose format cells and choose percentage and keep 2 decimal places according to the rounding requirement, right? So, and the weighted average cost of capital for the project is that 10.75. So final part of this question, the finance manager believes that the solar water heater project can support 50 cents of debt for every dollar of asset value. That is, the debt capacity is 50 cents for every dollar of asset value. Solar water heater. Hence, she's not sure that the debt to equity ratio of 0.6 used in the weighted average cost of capital calculation is valid. Based on her belief, the appropriate debt ratio to use is. So this final part of this question is simply changing the capital structure of our project. Before, debt equity ratio is 0.6, hence debt value ratio, as we just calculated, is 37.5%. So now the manager believes that this project actually support a higher debt value ratio. So now it's 50%. 50% of the firm value is can be financed by debt. That's simply what the first sentence tells us. Hence, 50% of the value, asset value, can be financed by equity, right? So based on her belief, the appropriate debt ratio to use is simply 50%. So the first part of the question is very simple. It's just a no-brainer. It's based on the first sentence, tells us the new capital structure basically. And the weighted average cost of capital that you will arrive at with this capital structure is, so basically every other calculation will be the same, but the only thing that will change compared with part C, what we did for the part C is to change the capital structure. So that's another benefit of using Excel, because I can just change this to be 0.5. So everything else will change because I just used the cell value. I didn't directly type, hard code the values. So that's another thing you have to. It's better to use the cell value to input the cell number rather than hard code the value. You see that once I change the debt value ratio to 50%, the equity value ratio will be automatically calculated, 1 minus that, which is for 50%. And the beta the equity beta, levered equity beta will also be automatically changed because I use the sale number. Hence, the cost of equity will also be automatically changed, and everything else. So I can just directly copy this number here. So it's the new weighted average cost of capital will be 10.71%. 10.71%. That's the final part of the answer. So now let me check my work. Okay, so it looks like we have got every number right for this question. So I hope that by using this question as an example, I have shown you how to use the comparable firms to figure out the weighted average cost of capital of our project. So the key is to do the unlevering first, using the capital structure of the comparable firm, and then do the relevering based on the capital structure of our own project. So that's a very, very important point, and it's also very easy to miss. You have to use the two different capital structures. Okay,